Hi, I'm Kathy Cherilyn Ogomben, and I will be reporting on a research paper entitled Integration of Technology in Teaching Mathematics. The Integration of Technology in Mathematics by Dean Mutadi, Wayudin, B.G. Qatar Sasmita, and R.C.I. Framana. And this is the abstract of the paper. So this paper presents the transformation of technological, pedagogical, and content knowledge, or TPAC, of 3 pre-service math teachers. They participate in technology-based learning modules aligned with the teaching practice taught school and became characteristic of teaching method by using the mathematical software. ICT-based learning environment has been the demand in practice learning to build a more effective approach to the learning process of students. Also, this paper presents the results of research on learning mathematics in middle school that shows the influence of design teaching on knowledge of math content specifically. And here is the introduction of the paper. So a teacher with the knowledge TPAC assumed to be able to figure out how to integrate technology into specific content and can apply the pedagogy most appropriate. Teachers in the 21st century are expected to be able to find out how to integrate technology into every aspect of education, such as curriculum design, implementation, management, and evaluation. Therefore, it is very important for a teacher to come with the knowledge TPAC to survive in the education system in the future. Recommendations from the Associated Mathematics Teachers Educators states that the teacher education program should provide the opportunity for teachers gain the knowledge and experience necessary to incorporate the technology in context, teaching and learning of mathematics. The theoretical framework of TPAC, built on the framework of PCK, or Pedagogic Content Knowledge, belongs to Schulman. Basic assumptions of this framework are that the teacher's side of knowledge about technology and optimization of combined in the classroom is a balanced combination of content, pedagogy, and technology. Harris and Hofer mentioned that TPAC has something special, the application of knowledge-based content that supports the high integration of technology. Based on Figure 1, TPAC is the center of the model, a representation of the slides of the following knowledge. 1. PCK, how to teach specific content-based materials. Number 2, TCK, how to choose the use technology to communicate with the knowledge content. And the third, TPK, how to use a particular technology when teaching. So TPAC ability of a teacher can be achieved when the teacher knows how technology tools can change the pedagogical strategies and representation of content to teach a particular topic, and B, how the technology tools and impact on representation understanding of students against the topic. Therefore, it is important for teachers to learn how to have the ability of particular content domain, TPAC for learning, to be more effective, and the need to develop a design-based guide to assist him in the TPAC, the process of teaching. TPAC framework concept can give a new direction to describe the instructional idea in solving problems related to the integration of technology into teaching and learning practices as the theoretical basis for developing curriculum in teacher education program. Research on teacher education reported that the TPAC model could be used as a potentially useful framework for preparing and developing teacher competence in school teaching. So the purpose of this research is to explore technology-based learning approach in the context of the preparation and development of the competence of pre-service mathematics teacher to face the challenges of the changing flow of information and communication technology move more quickly. This article represents an exploration of the transformation competence TPAC for pre-service math teacher and how to integrate technology into teaching and learning mathematics of high school students. These are the methods used in the research. Participants of 217 pre-service math teachers at a university in the town of Tasikmalaya have been taking computer courses. For research, 3 pre-service math teachers in this program are invited to participate in a study. Participants in the study This case study is 1 female and 2 males, and those aged 22 to 23 years. All of them have satisfactory basic ICT skills, but they do not have the experience of using ICT for experiments in and teaching mathematics in the past. The use of mathematical software in learning participants are introduced to the use of mathematical software such as GeoGebra, Capri, and Geometer Sketchpad as a tool and medium for learning mathematics. The module created presents examples of materials that can be taught by using the software. So after completing the learning presentation using mathematical software, participants are encouraged into critical open discussion forums to consider the potential impacts of technology-based teaching methods based on the TPACK framework. The critical open discussion in this case are consistent with the criteria for ICT TPACK consisting of A. The identification of the appropriate topic to teach with the technology. B. Identification of appropriate representation to change content. C. Identification of teaching strategies that are hard to do in the traditional way. And letter D. The selection of the right tools and pedagogical use of their capabilities. And the identification of the right integration strategies. To investigate the TPACK transformation from the 3 pre-service math teachers who participated in this research to instructional design task by using mathematical software into practice teaching and the learning process of students. The task of designing the first given to a participant in the first week with learning materials using mathematical software. Before the first case study presentation, at the end of the learning materials, participants are assigned to complete the task of designing the 2 using mathematical software into practice teaching and the learning process of students. Also, the result of the study conducted with high school students put up on the units of analysis are related to present experimental results, the use of mathematical software in teaching practices. For analyzing transformation competence of TPACK 3 pre-service math teachers using the analysis of the content in writing systematic design task, the coding system of the rubric with the TPACK framework developed and then encoded based on the design for the task, the 7 categories defined by the TPACK framework, namely CK, PK, TK, PCK, TCK, TPK, and TPACK. The result, the first pre-service math teacher, PMT1. PMT1 is a male 23 years old, has no teaching experience, has no work experience, proficient using Excel, and can use GeoGebra. Mathematical instructional design tasks with the TPACK framework can be summarized in Table 1. For the preparation of instructional design, PMT1 chooses flat-side geometry topics with the material properties of the cube for DLM1 and the surface area of the cube for instructional DLM2. On DLM1, PMT1 identifies content from the properties of the cube, such as the shape of the side of the cube and the position of the sides and the position of the ribs. PMT1 describes learning cube properties by observing the shape of the sides of the cube, the position of the sides of rib, and positioning of objects that exist in the classroom or instructional media are presented. So the use of software GeoGebra also shown to have more details about the properties of the cube, especially avoid misconception students at space position of divination orthogonal. However, the PMT1 did not explain link between content and presentation, how to use GeoGebra software in learning. So the third component of this, given the PMT1 alternative nature functioned as a supporting idea in justifying the previous explanation. On DLM2, the PMT1 described the surface area of a cube, CKPN, how to find the surface area of the cube, PKPN, as well as the use of GeoGebra to explain the steps of determining the surface area of the cube, TKPM. The relationship between the content and pedagogical knowledge explained that to be able to find the surface area of the cube, the student should understand the breadth of each side of the cube, PCKCM. The area on each side of the cube, it will easily be understood when it is displayed in the net mesh cube served in GeoGebra, TCKCM. However, the PMT1 did not explain in detail about the steps that represent the representation of this topic in GeoGebra. Transformation and the use of technology emerging from the result of students' difficulties in the identification with the observation of the media presented, TPKPN, the PMT1 conceptual relationship between mentioned content, pedagogical and technological in the LM2 TPCN, example by the revealing the need of technology to represent the shape of the surface of the cube so that facilitates students in identifying the area outside of the cube. PMT2 is a 24-year-old female. A private tutor does not have the experience of teaching in schools, can use Excel and know the software GeoGebra but have never used. Mathematical instructional design tasks with TPAC framework can be summarized in Table 2. On the LM1, PMT2 identify materials about calculating integer operations, CKCN, and how to transform the operations of subtraction, multiplication, and division into the summation operation, as well as using the inductive way to indicates that the negative multiplication by the negative is positive, PKPN. CK needs to be delivered through the use of computer technology, TCKPN. Since GeoGebra, Cabri, or GPS, so the shape of the operation of subtraction, multiplication, and division, and does not appear as though it has been superseded by the operation of addition, TPAC-PN. The use of computer technology is meant to visualize forms of positive number and negative numbers, TCKPM, so that the students can distinguish between the sign of the number with the mark operation, PCKPM. On the LM2, the concept of the linear equation of one variable, LEOV, identified by PMT2 about the use of the concept of operation to calculate an integer, CKPN. Because the term segment is a new concept for the students classes 7, a representation of a segment must be changed into another concept that is easy to understand students PCKPM. Example, through a visual representation, TCKCN, so the term variables and constants are perceived by the students as if real, TKPM. Students must have the perception that the addition and subtraction of a variable are essentially the same with the addition and subtraction of constant, PKPM. Computer animation is very supportive towards learning. This because representation variables and constants are easily to modify, TPKPN. By showing the relationship between CK, PK, and TK, PMT2 has a good understanding of how the integration of content and technology pedagogy, TPAC, CN, so that the delivery of the material linear equations, one variable LEOV, the nature of mind, can be a hands-on activity. On the LM1, PMT3 identifies the difficulty of students on the material geometry in determining the corresponding position, either side of a corresponding or corresponding angle, CKCN. The result triggered the use of computer technology to acclip right position between waking up so that the corresponding position TKPN. Thus, students can easily observe a corresponding side TCKPN to form the equation geometry is right, PKPN. Students can easily change the position of some images being mutual position corresponds to the way some wake up that will be adjusted, TPKPN. The way is a technique that is good especially for students with low space divination, PCKPM. PMT3 has a good understanding of the relationship between the PK, CK, TK, and delivery of TPAC-CN. On the LM2, PMT3 identifies the concept of balls. CKCN is an abstract concept compared to wake up other spaces. PMT3 looked at that space is a vast awake pedestal times height when the socket and its roof congruent, and 1/3 wide times base times height when only has the base and had no roof, PKPN. The ball appears to be different from the other room, but PMT3 has the perception that the concept could be applied to other room, wake up, to find the formula volume sphere, PCKCN. When the bottom quadrilateral is input point on blanket and its vertex at the point of the ball is placed in the center of the ball through the virtual image TCKPM. The students will easily the pedestal of N is a square blanket pine fruit balls TCKCN. Furthermore, students will immediately be able to find the volume of the fruit in N pine quadrilateral example 4 pi r squared times 1/3 x r TPKCN. PMT3 identifies the relationship between CK, PK, TK, which is actionable in the real application in learning TPAC. Implementation of learning at the school of the 3 prospective mathematics teacher is teaching practice in experiment results of applying learning by using the mathematical software. The findings in the field show that understanding TPAC pre-service math teachers affect the practice of teaching mathematics in the classroom, and instructional practices affects the conceptual understanding of middle school students in the field of mathematics. For the discussion, empirical findings provide evidence that understanding TPAC conceptual of the 3rd pre-service math teachers have undergone a transformation and improvement of knowledge that is generated by the following training using learning software math. Also, the findings also show that math teacher candidates on TPAC task design both have higher level of competence than the first design task. In more detail, it is interesting to note that prospective teachers of mathematics 1 have resulted in the perception of the PCK, the conception of TPK and TCK for the development of competencies at the level of the conception of TPAC. Also evidence that TPK and TCK PMT2 has changed the perception of the level of conception similar to the PMT3, who has changed PCK, TPK, and TCK at the perception level to the conception level. According to the transformation of their knowledge, the level of competence of the TPAC for PMT2 and PMT3 need to be developed to a higher level, from conception level to conception and action respectively. The result of this research showed that the technology-based learning has a positive impact on the development of the competence TPAC of a pre-service mathematics teacher. The result is because the use of technology-based learning materials for model TPAC pre-service teachers something to do with the knowledge content with changing shape significantly TPAC. Moreover, consistently, research findings stating that technology-based teaching for teacher professionally competence development led to a significant change in the learning activities of high quality. In conclusion of this research paper, this paper reports the use of technology-based learning approach to developing the competence of pre-service math teachers, TPAC, and transforming knowledge in integrating technology into practice teaching mathematics after technology-based learning training. In an effort to better serve the needs of the high-quality mathematics teachers, the result of this case study illustrates that competence TPAC can in particular be regarded as core attributes for future math teachers. The result of learning model with using the tools of technology can help students develop an understanding of mathematics and mathematics teaching method practices affect for teachers. Also, the competency of the TPAC mathematics teacher can have direct impact on student learning in mathematics lesson. The result of this study showed that the technology-based learning approaches can be effective role in preparing and enhancing competency TPAC for teachers in mathematics. And this is all for today, and thank you so much for listening on my report on a research paper on the integration of technology in teaching mathematics.